In this stage, your server will extract the URL path from an HTTP request and respond with either a 200 or 404 depending on the path. HTTP request. An HTTP request is made up of 3 parts, each separated by a CRLF. So this is the request coming in, not the thing going back out. So we have the request line, 0 or more headers, each ending with the CRLF. So request line, so this would be the request line. Then we have headers, optional request body. Sorry, it looks like this is the full header. Then another header, and then body down here. Here's a breakdown of the request. Okay, so we have request line, we have a get, so HTTP method, we have all that stuff. That's great. The request target specifies the URL path for this request. In this example, the URL path is index.html. Note that each header ends in a CRLF, and the entire header section also ends in a CRLF. So we're going to need to do a little bit of parsing and looping here. So that's going to be fun. So first, the tester will send a GET request with a random string as the path. So we expect that to be a 404 response. Then the tester will send a GET request with the path /, and your server must respond to this request with a 200 response. Okay, that seems perfectly fine. You can ignore the headers for now. You'll learn about parsing headers in a later stage. In this stage, the request target is written as a URL path, but the request target actually has 4 possible formats. The URL path format is called the origin form, and it's the most commonly used format. The other formats are used for more niche scenarios, like sending a request through a proxy. For more information about HTTP requests, see their documentation. Excellent. Okay, so first off, we should probably just see if we can get the entire request and see what that is and print that out. So when we get our stream here, let's see if I can just grab the request out. So let's do, we have a request equals stream. What, I thought I could scroll on these now. Oh, is that only help stuff? Now there's read to end. So I wonder if read would work. And these are snippets now. Okay, so peek. Okay, so I don't think we want a read timeout. My guess is that I could read the entire message into a string, which should be fine for this server, because I don't think we're going to run into a problem of everything running out of memory. Now, read vectored, like read, except that it reads into a slice of buffers. Data is copied to fill each buffer in order with a final buffer. I don't know how much of that I care about. And then read just pulls in some bytes, and then I have to just deal with that myself. Let's try read to string and just see if that works. So first off, you want the string. Okay, so then, this is going to be the size. So I want to do something like mute, sorry, not mute. This is going to be a string new here. We're going to make you mutable. We put in a mutable reference to the request. We're going to context and just say reading stream $u. And then let's go ahead and debug the stream. Stream? No, the request. And see what we got. I suppose I should spell things correctly. That would probably help. Diablo, hello. How are you doing today? Cat? It's a good question. Okay, next ad starts in around 30 seconds or so, it looks like. So let's go ahead. During the ad break, I will go find Cat and bring him in. I guess in the meantime, let's go ahead and run this and see if we get anything printed out here except error. I see the error dot here. I don't see the squiggly lines. No semicolon. That would do it. Okay, there we go. So if I curl and we just go to just something like that, I don't see no debugs happened. So I don't think that worked the way we expected it to. All right. So we're gonna have to figure out how to actually read the bodies. Read a string is not what we needed at all. So I'll probably actually have to read into like documentation of TCP string or something like that. But that being said, I'm gonna go find Cat. Omnifitus, hello. How are you doing today? Okay, well, the ads are starting there we go. Ads just started. I will be right back with Cat. All right, I'm back. We have Cat. He's not in his like super like hanging out phase. His name is Zilby for those of you who are new here. He's he's a little bit over 3 years old. He's been hanging around with us. We had him on stream, so he's been with us since like he was around, we think, 10 weeks old. He's a rescue, so we're not completely sure. But he's a pretty standard American mid fur cat. So he's not a short hair, but he's a standard American cat. He has one brain cell because he is orange. Exactly. Are you stand over here? You want to look at the mic? No? I can't tell what he's looking at. Like we have some blinking lights, we have just like the microphone up here. He's not purring, so he seems like engaged. Okay, you wanna look outside? I'll open a window for you. You have to get off me. Just hang out here. No? You wanna hang out on me? Oh, I've not set up the cat cam. Okay. Well, that's a problem. It's a problem that Zilby solved by just jumping down, so the cat cam won't be able to see him anyways. He got offended when hearing he only has one brain cell. That's probably true. He's gonna hang out on the floor next to me. He's been doing this when I'm not streaming recently, hanging out on the floor down here as opposed to like up high where he can look out windows, which is strange because I always thought that he loves looking out windows. But okay, what did I miss? Let's see. Read to string doesn't work because read to end string doesn't return until the stream closes on the other end. It might work if you control C and curl before control C in the server. Oh, okay. That explains that. Okay. So, okay. So, read a string won't work because it needs it to actually end and finish writing essentially for us. But we're reading just sort of like this ongoing thing coming in. So instead, we need some other read. Now we have just read, pull some bytes in, but we need to know how many bytes, right? And do we know how many bytes? I don't think so, right? Now there's read vectored. Oh, actually, no, wait, this doesn't tell me how many reads. It's just gonna pull this in. Okay, so this maybe we can just do this. Also, Chantilly, hello. How are you doing today? So if I just read, let's try you. So if I read, we read into the request. Now, you won't be able to do this. We're gonna make you be just a good old array. And now if I print you, that's not really gonna look that great. Like it will work, but I would probably want to turn this into a string or something like that. And let's see, what can I do with a reference? Oh, you got today? Oh, right, because Labor Day. I keep on forgetting, like I even mentioned it at the beginning of the stream, but I already forgotten that today is a holiday. Okay, so request dot, what can we do? So I don't want to bytes. Oh, wait, it's not, it wouldn't be, I can do like a string from bytes, right? So can I do like a stream? Oh, can I do stream? Oh, sorry. Request to stir. There's like as the pointer. I don't think that's what I want. None of that. Can I do a string from UTF-8? That's a vector of U8. Isn't there like a from bytes or something like that? That's a zero size array. It'll only read 0 number of bytes. Oh, you're right. That would, yeah. How do I know? Okay, so how do I know how big this is going to be? Or can I hand it? Okay, so string from UTF-8. Okay, so that'll work for that. But you're right, Skimmus, that's going to be a problem here. Is we need to know how much of this stuff is coming in, which includes the body, which is unknown, right? Although I suppose if we think about this, we know that we're going to have this, right? Oh, this is unknown because that could be a different size. Generally with read, you handle it like OU8, 512 or something, and read returns the number of bytes read. Just give it something really large. Probably just want to keep calling read until the returned read size is 0. Oh, so I could basically just create a bunch of these, concatenate it together with something else, and just read it over and over again until we reach the end of it, which does sound appropriate. And that does sound like an appropriate first function for us to do. I'm going to do it down here as opposed to creating another file. So if we have something like a function like read stream, let's say, so we're going to take in the TCP stream. So we can take ownership of it here because can we? Do I need to take ownership of this here? Or can I get away with maybe a reference to it? Let's try a reference first and see what happens. And we're going to return a vector of probably U8, so bytes essentially. That has the same problem as read to end string though, because the curl doesn't close the stream until curl considers the request finished. Okay, so wait. So I can't read until the return size is 0 because the return size will never be 0 because it's a two-way open connection, essentially. Or, no, it's a one-way open connection from client to server. And they could be streaming stuff to me, and so the size is never going to be 0. Is that what you're saying, Japfo? Because that would kind of suck. Now we know if we're going to get, I could just read this in chunks and just sort of like randomly choose how many chunks to get it. And that, I think that's what you were talking about with the 512. So just get it in chunks of 512. Yeah, the size will be 0 when curl closes its end of the connection. But of course, we need to respond before they close. That would be helpful, right? Okay, so if I want to, let's just do the 512, the chunk size. So if I do like let mute, I'll just call this chunks for right now. We'll call this request chunks. I think what I want to do is actually just we're going to start with a request, and that's going to be a new vec. We're going to return the request at the very end. We are going to then have to do an infinite loop because we don't know when this is done until we hit both CRLFs. That's what we have to look for, isn't it? So we do an infinite loop, and we're going to have to now get a new chunk. So let mute chunk is going to be equal to an array of, now you had OU8, right? What's the OU8? Yeah, you had OU8. What's the difference between, what's OU8 versus just U8? Because I could just do that too. U8, then we'll do 512. Oh, it's a 0. That is a font problem. I thought maybe like an O was like a special thing. It was like, no, just fill it with zeros that are U8s. I can do that too to like make it a little bit more obvious. Okay, makes sense. Got it. Hey, thank you, Isitsu, for that. Okay, so we create a chunk here. Is there a reason I decided to put a bang there? I don't think so. It's not a macro. Okay, so we have our chunk. I want to now read this chunk in from the stream. So we're going to do stream dot. Now, I can't read to end for the same reason I can't read to string, right? Because there's no end for this. So I want to read, pull some bytes from the source into the specified buffer, returning how many bytes were read. So I want chunk. I probably need to know how many were read for this so that how many read. We will context this. The context will be, and also you get banned. Okay, so context is going to be reading chunk, reading request chunk. We'll question mark you. Now, this means that you need to be, let's see, you're a vec. I want you to be a result that we return a vec u8 in. That's great, which means you need to be an okay with the request. Okay, that's great. How many read? Okay, so, stream. Cannot mutate in variable. Okay, so you can't just be that. You need mutable reference. How many read? Okay, so we're not using that yet. But now we have a chunk, theoretically. And we do this infinitely. And so when how many red is 0, even though it's not closed, there's nothing more for me to read, theoretically, right? Like that's the theory here. So if how many red is equal to 0, then I want to break. Yeah, I want to break out of the loop. And then we're going to take in the stream read. So we're going to take this chunk here, and then I want to append this. So request append chunk, which is a vector. The other has to be a self. Do I have to turn this into a vector? Wait, there's a concat too, right? A concat takes t. Okay, so a concat, and we hand it chunk. This method takes 0 arguments, but oh no, that's not good. Also, you also get banned. Yeah, it's just gonna block on reading, which is not gonna be fun. So this one is like, this is not sure if correct. That's one thing there. Concat. Trait bound, U8 concat is not satisfied. SS concat. So wait. I can't concat from the other thing. Oh, extend from, oh, that's what it was. I think we've used that before. Request, extend from slice, chunk. There we go. Expected a reference. It's fine. We can do that. There we go. Perfect. Thank you, Japo. Okay, so now this gives us it gives us a test here because we don't know if this is going to work, right? There's a couple different things that like may or may not work about this. For example, we're pretty sure the chunks are going to work. How many red may never become 0, so we may never exit this loop. And yeah, the fun things about that. Rishi, hello. How are you doing today? Now, what we can do is we take okay, so we have our stream like that. I want to take our request, and we're just going to call read stream and pass in a mutable reference to stream. We're going to context this and just say reading stream like that. Now this gives us a vec of U8, and I wonder if I can turn this safely into a string. Let's find out. Do you go for a buff reader and read line until you have all you want? Ooh, that's another good suggestion. So we can do possible ideas. So buff reader and read line. That might work. We should let's add that. We'll try that out next. I want to see what happens here. Now if I take this request, we're gonna do a string from UTF-8 and to the request. Let's just question mark you. I don't need the context for you because we're just doing this as a test. Anshul, hello. How are you doing today? You did this challenge in Rust last month. Nice. How was it? Okay, you're running. Let's go ahead and curl this. And I saw a lack of messages popping out behind me. So that means that none of this worked. Okay, so what we're going to need to do is throw in some debugs or some print lines to sort of like see where things are happening. So for example, if I do a print line here, we'll just say like starting to listen. That's an option, you guess, but readline would also block if you don't get what you expect. The real solution is using non-blocking IO, but I think it's beyond this exercise. A hack that could bypass this all would be using TCP stream set read timeout, so you get an error on timeout. Oh, we could, yeah, we actually have access to that. So we could set the timeout so you get an error on timeout. Same issue that I'm having, the stream was not ending. I think you ended up using a constant size buffer. Oh, what Japfo said. Okay, so you set the timeout, but then also a constant size buffer. So I am setting up to use a 512 size buffer here, but then I do this over and over again. But yeah, and I think what we need to do is in here parse through until we see the double CRLFs. Rishi, you're doing great work. Keep it up. Thank you very much. But more importantly, I didn't get this coming out. So something happened I am blocking on something and not getting to where I want to get to. So my favorite way of debugging this is the good old print lines everywhere method. One thing I can do, let's switch over to a cargo watch run here. Do I want to run? I don't think I want to run. I think I want to do a cargo watch. I think it's C for command, and then that is your program. Found argument watch. What did I do? Cargo watch, which isn't expected or isn't valid in this context. That's interesting. Where was that error from? What's happening in your program? Set environment variables. You cd into, you build release, and then you exec it. Okay. Changing this script will not affect how CodeCrafters runs your program. Right. Because I could totally just like cheat in here. So they don't actually use my script for real. I wonder if I just did, okay, cd into the appropriate directory. If I do a cargo watch, I think it was -x run. Now you're using a -- release, which I'm not sure I necessarily need. And then exec this with, don't know what that does. Oh, this will this just does a build on it. Okay, so I build it and then we execute and run it. I bet that we could just do over here. I can probably get away with a cargo watch X run with this. That runs that. And now I can curl these. And I should be able to see whenever I make any changes here. Yeah, then it rebuilds. So we have starting to listen. There it is. Okay, starting to listen. That's great. So we get you, and then I want to maybe receiving incoming message. There, receiving incoming message. Excellent. Okay, so I extract out there. I get the request. Now, so if I do something like got request, receiving incoming poorly spelled message, but we never get this request. So now we know that it's in read stream here. This loop, my guess is never exits. That's my guess here. And so if I do something like print line about to read stream, let's print line looping while getting chunks. And then down here, we'll do a print line got all the chunks. Okay, so if we do that, my guess, 2 looping while getting chunks. Excellent. Now, let's see how many we actually read. Let's try a debug of, let's just do a print line. Print line, we read, how many read? Chunks. Okay, starting to listen, receiving incoming message, about to read stream, looping while getting chunks. We read 88 chunks. Looping while getting chunks, because that was less than 512. But if we think about this, if we read less than our buffer, then that means we have read to the end. So if this number is less than that, we are done and we can exit out of the loop and we're fine. Let's see. I cannot read your user name. But hello, how are you doing today? Your thumbnail is very simple. You like it? Thank you for that. I've been experimenting with like actually putting my face on thumbnails, making the face bigger, but also keeping it nice and simple. So hopefully I'm working with that. What do I mean by HTTP server? So HTTP servers are like the backbone of most sort of web JSON or other types of servers that you might use. So if you've ever created like a Node.js server using Express, or you've created a server with like PHP Laravel or Python Django, it's basically one of those, except very, very, very simple. We are not creating a framework around it. So also open source. Hello, how are you? This is not an Axum web app. This is we're doing a challenge to create an HTTP server which would be closer to tower, which Axum uses behind the scenes. Does that make sense? Excelion, I have, my brightness is not high enough to read the color that Twitch decided your username would be in. Hello, how are you doing today? Am I planning for HP 1.0 or 1.1? 1.1 it looks like, because they're having me return that as part of the header, which we can see up here. So 1.1. All right, so let's have a buffer size, and I'm going to set this to be extremely small right now. So we saw that this was 88 chunks, which if I move out of the way, you can see that a little bit better. Now, if I do this, let's see, I don't want this to be even. Let's do this 40. So here's our size, 40. And I want to use the buffer size here like that. Attempt to use a non-constant value in a constant. Can I put a constant in a function? I feel like this would be the beginning. Okay, fine. Go down. This is potentially the reason to put this into a different file. But okay, so if I put this as like 40 here for right now, and 88, right? 88 is going to be 1, 2, and then on the third one we exit, right? So I should be able to see we read 40, 48 chunks. I'm going to keep this as how many we read to keep it as blocking, but that's the goal. Is I want this to see this as 40, 48. So if we run this, and that's exactly what we see here. We have 40, 48. Multiple write calls on the client, and could end up with separate successful reads on the server with less than 512 bytes read. It probably works in this case, though. In practice, some buffering happens on the OS level on both ends and probably in routers in between. Like, imagine if the client calls write once for each header. Yes, and actually this is something that happens in, I don't know about like some of the other frameworks I've used, but like, for example, in programs I've worked with in Node.js and Express, it is absolutely possible to do something like, hey, we're going to write out, and then also, hey, we're going to now set a header. And you do 2 writes then, and weird things might happen, which is always interesting. Annoying. HTTP 1.0, you could use content length, you can use a buff reader, and lines take while is empty to get the initial request line and then do it again for the headers. But we're going to hit the same issue for body. Yeah. So also, can I run this? I am running it right now down here behind me. So that's the logs for me, like running the actual program. So it's constantly running. All right. So now that I know that's working, what we could do is I can set this back to 512 or something like that. And really what I want this to be is if how many read is less than, oh wait, I can put const anywhere? Oh, that changes things. So can I do const buffer size? So let's do 512, buffer size like that. And if you're less than or equal to buffer size, then we break. Okay, so if I do that, are you a U size? Can I make you just a U8, an E8, a U8? What do you need to be? You need to be U size. Okay, so there we go. You're working now. So now I should get all the chunks and return that. And then we're going to try to print everything out that we got. So let's do this. Okay, so we got request get. Okay, so here's our request. It's a get, and then that's our path that we handed it. I'll full screen this so you can look at all this and its beauty here. So get the path HP 1.1, CRLF. We get host. So there's a header. We get the user agent header. We get an accept header, and then CRLF, and then an empty by. These are headers, and then we get serial F, and then I think an empty body and then serial F. I think that's what that is. And then all the zeros are just because we went with a 512 size chunk, and these are all the unused ones because we initialized them with zeros. That's what's going on there. Okay, so I mean it makes sense. We actually got this now. Oh, you know what? I don't have the auto change theme. For some reason, the thing broke, and I need to fix it sometime. But let me know what theme you want to change it to, and I will change it to that theme. We haven't had a change theme in a couple streams though. Everblush. Actually, Can I do this manually by hand? I don't remember if I ever set that up. Okay, I'll just do it here. Theme Everblush. Ooh, it's a very subtle change, but it looks nice. Wouldn't this break on a body larger than 512? It shouldn't, but there's a way for us to test that, right? Because I can just come to my chunk size, and let's just set this to be something absurdly small, like 8. So if our chunk size is 8 now, it should be reading 8 little bits at a time and then sending that in. And we know that we have an 88 size body. So if I write you, I feel like this didn't, why am I down there? Okay, I feel like it went way below my buffer size, which is fun. Okay, so if I find stripe, I want to do a curl. I did a less than, or break if it's less than or equal to, which you're right. That is wrong. It needs to be less than. Okay, now we get all of these. Oh, because it's exactly 8, it doesn't work. If I make that 9, then that works. Okay, that's fun. That was a fun one. So now Acceleram, it shouldn't break on anything larger than 512, but I think it was going to break on it. Let's see. You don't know about Rust language, what field cover? Rust covers, it's a generic language. So by generic language, that's similar to C, C++, Python, Node.js, Java. Basically, it just means that it is a language that can do pretty much anything that you want. It's not like hyper focused on one specific domain. It used to be billed as a systems language, but the Rust team no longer really focuses on that messaging anymore, mostly because they just want it to be more inclusive to other developers. But it can be very fast. Like it tries to run as fast as possible and also have a lot of modern high-level programming sort of helpers set up for it. Am I a Mac user? Yes. So you can see I am running Mac right now. In our region, Mac is so expensive. We are using cracked Windows or Linux most. Yeah, I totally get that. Like especially outside the United States, like it can be really tough to get Macs, or even just some of the other computers, right? Because like there's a lot of pre-built computers these days that have gotten themselves up to the same price point that Mac has. Do I know PHP? Yes, I do know PHP. And at my last job that I worked at, or I guess the job I still have a contract with that I'm working at, we do have one PHP project. It is a PHP 7 dot something, and we're running Laravel and Yi in the same project, which is, don't think about it too much. It'll break your brain. Just try not to. But yeah, it's fun. Let's see. Yeah, now it'll break on a total multiple size of 9. Yes, that's true. Changing a buffer size won't really fix it, but now I can, every time I run into a problem with it, I could now just change the buffer size to something else, and then it will work. Okay, so I probably should do extend from slice chunk how many red instead, so you don't push all those zeros to the request vec. Oh, yeah, that's a good point. I probably should do something like that. And then the other thing would be the buffer size, figuring out like how many red read up to it. Unless you coincidentally change the size to another factor of the total size. Yeah, which is possible. We can do like, okay, we're going to do 9. Let's do 3. That'll work, right? I mean, 18 might work, but yeah, I could totally see like weird problems like that. Now, I can't. It would be hilarious to do something like, hey, we're going to do 18.5. Okay, so I put in an illegal number there. I wrote in 18.5, and is this the theme? Did the theme make my text disappear? As soon as I put the dot, it disappears. That's weird. I think that must be the theme, right? Okay, so if I do that, and then the other thing was extend from slice, and then we can do, what was it? It was ... how many red, to not put any zeros. And so now if I put in something like we want 1024 size, and we print out what we get, we should not get all of the zeros. Perfect. You are not allowed to use illegal numbers. Yeah, that's true. If you can't see the errors, do they really exist? See, this is perfect, Nigel. We don't, if we can't see the errors, they don't exist, and therefore it's great, right? Like the second that you're like, hey, I want to use this as like a 0. Oh, wait, okay, undo. Just don't type too fast. Okay, so this is good to begin with. This might be a good comment to put in here, which is this buffer size could cause problems if it happens to be exactly what we end on. Simply cease to write any syntax errors. Or as another instructor that I worked with in the past has said before, just code it right. Never run cargo tests, never. I mean, I guess. But wait. No, that doesn't make it all disappear. Just writing it bad makes it disappear. Canva can make YouTube thumbnails. Yeah, that's what I've been using. I've been playing around with Canva a lot recently. Okay, so we've got all you're working, everything's great, and now we see you. Okay, so we have get to all of the stuff behind me. You only do logical errors anyways. Yeah, like we don't want hard errors. We want logical errors. The errors that Rust won't protect us from. Okay, so now this gets the raw body, the raw request, right? It's like this gets the full request. Now, if I want to break this, I want to parse this into its like parts, right? So let's do now that we've got this, let's create a function that we can call parse. I'll call this like parse raw request. We will take in that vector and we can probably own it, right? Because we're just going to convert it into something better. So let's do the request, which is going to be a vector of U8 is perfectly fine here, I think. So we don't have to like convert it into strings and have other weird stuff happen. And we are going to return, I don't know if we need to return a result. We're going to return something. So I'm going to put that for there for right now. My guess is we're going to return a struct, which we're going to call a request. So if I have like a struct request, we know, let's see, this first part, like get, for example, we know that that's going to be a, that's going to be the verb. Should we call it? No, that's not the verb. Is it a verb? Method? I think it's the method. So we have the method, and maybe we have an enum method, but in a cargo.toml. Okay, I only have anyhow bytes and this error. There is an HTTP. There is definitely an HTTP crate that I could pull in that gives us all the methods, and then I don't have to write my own, but I also don't know if we need anything more of it. So if we just stick as long as we can before we start like pulling other stuff in, and we just say, hey, we're just going to have a get, and I don't really care about this, right? And so if we say that I want this to derive debug, so I can debug this out, method is going to be the method. You're also going to derive that. Okay. So let's now figure out how we can create this method. Sorry, this request. So given this, we know that I want to go until I have a space. So I want to just read through this until I get a space, and then that's what I do. We can make websites, but it is hard to collect users, so we give up when users base too low. Infinity Free is offering free hosting and free domain with HTTPS. I mean, these days you should be able to find free hosting for just like simple web apps in a lot of different places. Like if you're a developer, you probably have heard like many different places to go. Like Vercel is one. If you know what you're doing, you can use Cloudflare. CloudFront with AWS and S3 is like practically free. It's like pennies per month at most for that. So there's a lot of there are a lot of very extremely cheap and free options out there. Ray March, hello, how are you doing today? Used Chomsky for your last parser, found it quite cool. I'm gonna see if I can do it without pulling in a library because I think that's what the crux of the challenge really is trying to get us to do, is like actually just do this on our own. Will CodeCrafters try to detect whether or not you're using HTTP crate in a project? You're supposed to create your own HTTP server. Oh, that's a good question. I don't know if they will detect that. That would be hilarious though if we just like, it's like, hey, Tower, or just like spun up an Axum server and it's like, hey, okay, it works. But yeah, what would be the point of that? It's this thing like CodeCrafters isn't cheap, right? Like CodeCrafters is one of those things where we're paying for it. Although full, disclosure for those of you who have come in since the beginning, I did not pay for it. I'm partnered with them. But if you pay for it and then you cheat on it, who are you really cheating? They're not really cheated there. I think it's the person trying to learn is the cheated one, right? Okay, so parse the raw request. Okay, so I want to read through this and get to the space, but I want to keep everything out here. Yeah, congrats, you fooled yourself. Exactly, yes. I've had, when I was teaching, okay, so side thing. When I was teaching at in classes, so at the code school, this was a thing that commonly came up all over again, like all the time. And we had several people from Teach From America who were training us to be, excellent teachers. And we asked this question multiple times. And the person who was sort of like in charge of the team, he basically said, look, these are adults that we're working with. And at some point in time, we have to just accept that the adults are going to be there. We can't like force everybody to learn. We can't just assume that people are coming in and paying a lot of money just to ruin their own education. Like at some point we just have to trust them, and if they cheat, that they cheat. They're not going to get anything good out of it. So that is something to consider and be aware of. All right, so parse raw request. Let's see. We should probably do this one character at a time because we have an unknown. So I want to, okay, so when doing standard parsing type stuff, I probably want like a let mute, just like the character. So like the next char that we're getting. And should this be an option or should it be just a null? Like I could say this is a none. Or we can loop through this. So if I just I don't want to name it char. So maybe do it as next char in request dot. Can I get chars? I guess that's U8, right? So next char may not actually be completely correct because I mean it's kind of a character, but it may not be an actual character. So that is something. I don't want to call it next though. Oh, next byte. So we could do next byte might be better. All right, I want to check to see if next byte is a space. So if I do something like const space, and I want you to be a U8 is equal to space. Can I turn this into a, there's something like B, that's what it was. Yeah, there we go. Okay, so now I can say if the next byte is equal to space, then we're done, right? So the first one here is going to be getting the whatever this is called, like the current method. So if I do let mute method, I could do this as like a string new, but I think this makes more sense to do this as just a vec like that. Londo, hello. How are you doing today? Londo, thank you so much for the subscription. Thank you. 29 months too. That's so many. Let's see. I am okay. You're chatting with each other. Perfect. Okay, so if the next byte is the space, then we know that we are. Can you see that? Kind of. Like I go this way. We're right there. So that means that I now have the method, but if you're not a space next, I want to push you in here. So I want to say else next byte, method, and we're going to push the next byte in. Now, if we get to this next byte space, then what do we want to do? I want to sort of like, we want to end, right? I want to end the for loop, at least for right now, because like in reality, I don't want to end the for loop. I want to go through and get everything here. And I'm thinking that maybe we're going to need some kind of state machine for this, which sounds like an enum. Because if I do something like another enum, this is definitely going to make its way into its own file, because this is going to become, all of this logic together is going to become its own thing. So this is going to be the request parse state. Okay, there. I did actually, okay. I wasn't sure if I was copying that into paste buffer or not. Okay, so I have request parse state, and I want to throw this into, okay, what are we going to start? We're going to start with method, like that, and we will add this in here, and then we start with, we should have a default, and we'll set method as our default. Okay, so request parse state, so that our state equals request parse state default. We get you. So if next byte, I want to go to next to go into the next state, whatever that's going to be. So move to the next state. But if next byte equals space, that's not how they all end. So that's going to be something else like this too. Caterpiggle, hello. How are you doing today? What's the benefit of Rust over other languages? I think it's sort of going to depend upon which languages we're talking about. Benefit of Rust over something like JavaScript or Python would be the really strongly typed system that you get access to. If we're talking about something like C or C++, there's a lot of there's an entire ecosystem for using crate and grabbing packages from other users really easily. And if it's something like TypeScript, then you get the benefit of a compiled language that's not necessarily like focused on web, that has like even stronger type system, that has all the same benefits of that, but can run faster. So things like that. Fearless concurrency, yeah, like the borrow checker is a huge thing. So like the memory safety stuff, if you're working in a domain that needs memory safety and you're working in something that might be considered low level, so that memory safety is actually like gonna hit you with the language you would otherwise choose. Like for example, if you're gonna ever work with something like JavaScript or Python, you generally don't need to worry too much about memory safety. Concurrency, yes, you do need to worry about that, but memory safety, probably not so much. C or C++, yes, then we're talking about memory safety stuff here But again, only if you're using stuff where you're needing to like, do fun stuff with memory, which is most real applications. And then Rust can help there. Is it always the best choice? No, there's other memory safe languages too. There's memory safe features in some of the other languages as well. Like even C++, from what I understand, I have not used it, has quite a few memory safe features that they've added in over the years since Rust has come out. The question is, are you going to use it or not? Rust, by default, basically says, no, you are going to use this or we're going to not compile. And if you want that as part of your language, then yes, Rust is an excellent choice. C++ is nowhere close. Okay. It's hard to tell where things are because I don't have any C++ people to like talk to about this. And online, it's really uncertain what are the actual features that are there and of just people talking about it, because people on both sides of like Rust and C++ and C defend the language sometimes a little bit too much and with facts that may or may not be true. Yeah, people can get very heated about this. Absolutely. Now, in the end, the only thing that's really important, right, is delivered software that runs and doesn't piss off its users. And so if Rust helps you do that better than any other language, then Rust is the best choice. If you can do that with another language, then that other language can be a really good choice too. So generally speaking, Rust is up there with a really good choice, not always the best choice. C++ has made some unfortunate decisions that make it quite hard to retrofit safety features. I guess like another thing to sort of consider is that C++ is old. C++ has been around since the time in which we all by we being humans who invented the internet and like all the sort of like infrastructure that we're running right now, assumed that we would never need security, like passwords on anything, because why would anybody hack stuff? So consider that. It's like before we like blame the language for like not considering this, they did come out at a time when that wasn't like we weren't even like imagining to create software of such complexity as we have now. You cannot write safe C or C++, so it doesn't matter if you delivered it or not, you failed. The thing is that though, I believe that isn't exactly correct though, because you can technically write safe C or C++, right? Like you can technically write it. I think the argument for something like Rust is that you want a strong single source of truth, so that'd be the Rust compiler and the borrow checker, that is heavily checked by the community to make sure that it is actually correct. That is then going to ensure that you're following safety as much as possible, right? Whereas with C or C++, every time you write something, every library that you pull in and use, it is got to be checked by the developer or the community individually themselves. You can't trust some other library that they're writing it in the same format and way that you wrote it yourself. There are plenty of static analysis tools and sanitizers for C and C++, kind of, that would give you the same safety checks as Rust. The problem is that the developers need to use those tools, and many are vehemently opposed to the idea, even without a valid reason. And we're actually seeing that a lot right now with the big fight that's going on in the Linux kernel community. Is a lot of it is less about, Rust is like not supported or bad, and more of it's different than what I've taught myself, and that's not great. And I can understand arguments for it doesn't work the way we want it to right now. Those are perfectly fine and valid arguments. It's different, or I refuse to use those tools or something else, that's not necessarily a valid argument unless you can pull in something else that like actually is but we can't do it without it. Yeah, I have seen the NASA guides on it. It's been forever though. I forgot those. You do mandate them in your company, but it certainly was a culture shift. Yeah. In the end, most of these things are culture shifts. It's all about culture. But okay, let's continue on. I wanna every time there's always the possibility that we end up just like turning it into a let's chat about Rust stream, which is good and that's nice. But I also do want to work on this. So all right, continue on. If next, so this entire thing is questionable because like if next byte equals space is not always what it's going to be, right? Because sometimes it's going to be something else. Like last time, I should copy paste this in. Okay, so this is parse the raw HTTP request that we got from the client. Looks like this is one line, right? So I could do that. So it looks like that. Can you even read that? This is really light and dark for me. Although I have like windows and lights like on the other side of me, so that does make it a little bit harder for me to see my own screen, which is fun. Okay, so I guess my eyes are getting used to it now. I can see a little bit better. So basically we get to here, and that's great. But these the CRLFs are going to be the next thing that we need to worry about. So it's not always a space. Like, for example, we do a space here, that's going to, well, mess things up. So I probably want to do something like, instead of parse raw request, or parse raw, maybe parse raw request has another function in here, which is going to be parse method from request. And then we take in that request. Let's see, if I take in the request, I probably want to skip a bunch of other things. Oh, random. Wait, can I do a random anymore? Oh, you don't let me choose a random. Hold on. Okay, so I can just close my eyes. Congratulations, Diablo. You chose a blinding theme. I just held tab and flashed the screen. That wasn't that great. Sorry about that, everybody. I probably should turn off the screen next time I do that. Okay, so we can see the comments better now. That's a good thing, right? Okay, so I probably want to take you all out. So you get the space there. I want the method here like this, and we do a for loop like that. And then we're probably going to match on the state. And so we want the request parse state method. And so if we're here, blinding to you use flat white. Oh, so you're already used to this. Okay. And then we're going to call parse from method. So parse method. Oh, but then what I want to do is something like have a request. I probably want this to be a request builder too. So like we have a struct. No. Yes? Maybe. I mean, there's a bunch of different things I can do about this. If I do something like method equals method is now going to be equal to parse method from request, like that. Okay. You're upset because variable doesn't need to be mutable. Oh, because I assign it later. Yeah. That's how that works. Cannot find value request, right? So you need to take in request here. I don't need to be a full vector. You can be a reference, a slice array of U8, which is great. Function takes one argument, so we give you a slice of request. Can't compare. Oh, because it doesn't have partial equal is not for that. So I want either a reference to this or I want to deref you, which can I deref you here? I can't deref you there. Oh, wait, I can do something like this, right? I guess I can deref you at that point. Yeah, that makes sense there. And then warnings. Okay. Cat or Pickle, you program in all black. Even the text is black. No comments. It's there. Okay, hold on. I knew it was somewhere. That one. Okay, perfect. Thank you for that, Skimmus. Okay, so we get that. Now what I probably want to do here is just say, if you're not equal to space, then go ahead and do this. Otherwise, we're done. So we break. That gives us the vector of these. I want to now return an actual full string. No, I want to turn the method that we're actually getting, right? So we're going to turn that method. So we want to, I mean, it's not fast, but I don't really care if this server is super fast. So I kind of want to just turn this into a string and then deal with that. That's one way to do it. The other way is that I actually just take these, like take the get to bytes and then compare that, which would also work. But if I do something silly like string, can I do stir from? Can I do stir method? I can't do like as stir here. I can only do this with a string, right? Impl from stir from method. It would be from vec of u8 for method, right? So I could do impl. Wait, does bytes do from stir? I don't think I can do that, right? Yeah. Okay, so impl from, we're gonna do a vec of u8. Okay, so impl from vec of u8 for method. Okay, so we get our value of u8. I don't need to convert this into a string, but I'm going to. So let's do our the string, like the raw method. Oh, there is a UTF-8 chunks, but what is that? What would that do for us? Okay, so rep from UTF-8 value. I could do a try from on this instead. That might be better. Is it try from? I think it's try from like that. What? No, stop. Don't try to update. Do that tonight. Oh, type error equals what? Can I do an anyhow error? Okay, anyhow error. Okay, now we have our try from value that, okay, does all that fun stuff. Yay. We get u value. So now I want to, what do I want to do? I want to let so like the method string, it's going to be a string from UTF-8. We pass in the value. I can I actually context this? I don't think I can. I think I can. Actually, you know what? I think I can do that. We are converting bytes to method string. And I can't. Can I question mark this? I think I can. It'll consume the vector, but I'm pretty sure that that's okay with vector right now. Yeah, we'll just take ownership of this vector. All right. So we now have this method string, and now we're going to match on a method string as stir, because why not? And so we're going to have, if this, method string, this should always be uppercase, but because I'm very paranoid, I'm going to 2 uppercase it anyways. And we're going to say, okay, if it's a get, then we're going to return a self get like that. So we match from you, and then I want to return this, right? So this becomes an okay like that. Mismatch types. For loop evaluates type nothing. Oh, because I'm returning parse method from request. It's going to return a method. Oh, because I haven't returned anything yet. Okay, don't yell at me. And then if you are an unknown, I want to anyhow. Oh, can I do this? Will this work? This let's do an error saying unknown method. Oh, I have to turn an error, don't I? So this is a shoot. Oh, can I bail? Oh yeah, that totally works. Okay, Then I just have warnings. Okay, perfect. So now we can, so a method, I get this. I now want to use a method from, try from method. And you are an anyhow error. So I think I want this to be just a result. Result with a method in it, like that. And then I think you're okay. Yeah. So now that gives us a method from the request. And so at this point in time, I get the method, and now we have the method in here. So context is getting HTTP method from request, question mark U, and now we have the method. So all of that for this. Excellent. Okay. All right. What's next? We haven't actually like done anything of any value yet. I guess we have this method. That's great. We need the what I probably want to do is actually print this out to make sure it's doing what we expect it to do. So down here in our run, we have read stream. Now I have this parse the raw request. You're yelling at me because you're should return a result or option to accept question mark. Yeah, you should. Now parse the raw request. I want you to return not that, but the request. So down here we're gonna have to do an okay request method. Okay, so now we have you. You don't need to be mutable yet, so I'll just go ahead and we'll just get rid of all the warnings. Okay, so parsed raw request is never used. So we need to use you in here, read stream. So we get the stream. So this gets us the full request. Actually, not here. So that gives us all the chunks. Okay, so here's the request, read stream. We get that, got the request. So then I probably want, so this is maybe the raw request. And then I want this to be the request is going to be parse raw request, hand it the raw request. Okay, that gives us the full request. Instead of trying to turn that into a string, we then just debug this. And there we go. Kubalim, am I running a server or a novel? It looks fantastic. Yes. Yeah, we'll just go with yes. Okay, so behind me, I should be able to see the request come out. So let's go ahead and do this. So if I run you, we get to see our method get. Excellent. Okay, so we wrote a whole bunch of code there, and it worked, which is amazing. Okay, so that's, of course, not everything that we need right now. We want... Because what we really need to do is find out about this parse. This path. That's what we need next, is path. Change Helix theme, anything dark. Thank you very much for that. I usually use Advaita Dark, so I'm going to go back to my default. Thank you for that, Ray March. All right. So, I want to... Parse the raw request. We get that request. Parse method from request. We try that. Struct request. Okay, so as part of the request, the next thing would be the path, and I'll probably just make this a full string, which will be fine. There's probably other things like I might want. Like if I had URL in here, I would put that in there, but we don't. So I'm just going to put path as a string, and we're going to deal with that later. All right, so errors. So we now need a mute. Okay, so I need a path like this, which means when we're parsing the state, I need to grab, okay, so parse raw request. Parse raw request comes after this. Where am I going to update my state so I know which the next thing I'm getting out of it? Because what I Do I need to care about that? I think I do. Or we can use a cursor. Because if I use a cursor, then I can pass that into the parse method from the request, and then I know where we're starting from the next time. Because now it's more of, okay, I want to parse this out of it. I've already parsed this. Why should I need to like skip the first bits again? I should probably use a cursor, shouldn't we? Now, can I easily do that? So we have this request here. So can I do like cursor? That's gonna have to be mutable. Are all the cursors in libraries, or is there like a default one in a standard library? Creates an adapter which implements the read trait for self. Okay, it's a struct probably in standard IO. So there's this reader. So if I do a reader like that, and then I do reader dot pull some bytes from the source into the specified buffer, returning how many bytes were read, mutable self. Does this mean that it's now at a new reader? I think it does, right? Read all bytes into buffer until the delimiter byte or end of file is reached. Probably not, right? I don't want to split. Okay, so if I did a reader, you're gonna need to be mutable. Okay, you're gonna be so upset at me, but okay, don't worry about it. So now if we say a mute reader of U8, right? Is it the reader's of U8? No, the reader is a slice. Oh, that's maybe a little bit odd, but okay. Okay, so we have U. I can't get the next one, so it's going to be the request. I don't want to transform it into bytes. Pull some bytes from the source into the specified buffer, returning how many bytes were read. Read until would be amazing. Read all bytes. Okay, so delimiter. Where's my delimiter go? U8. Is that what it is? So read until space. And then I read this into, okay, so this just changes how this works, which is going to be nice. Okay, so I want to do something like let mute raw method. So actually I can change this. So method, can I actually just do this as a vector? Oh yeah, it actually needs to be a vector. Okay, so perfect. So we're going to do request, read until you get a space. We throw the method in there, and now we have all of you in there. Okay. Do you have a return a result? So we'll context reading. I guess like getting method bytes, and then method try from method. Okay, I think that works. And so theoretically, this request reader is now up to date, like location wise in it to that first space. So we should be good to go with everything else. So, okay, so you're missing path. So now I want request from state. Did I not put in go until definition? Oh, I didn't. Okay, so this will be path next. Okay, there's a path. And then I want to say path is equal to, we need to do this. We need to actually implement it. So you have parse method from request. And so next would be function parse path from request. So we're going to have a request, which is our reader, and turn a result with a string inside. Let's see, what are we looking at? We are looking at starting from here into our next space. That's pretty much what it is. We're just looking for the next space. Spaces are not legal in paths is true, except technically it is possible to put a space into, okay, it is not legal to put a space, like a real space, into a URL when you're passing that to a server. You're supposed to HTTP encode them. So if they do that, then sucks to be them. And by them, it means me. So sucks to be me. All right, so I want another space here. And then we're going to essentially copy, we're going to be very close to this. So we're going to have let mute our, give me the raw path, give me the path bytes. It's going to be an empty vector. Then we're going to say, okay, for the request, we want to read until you get a space. The method, sorry, path bytes. So this is parsing path from request. Okay. Once we have that, then I just turn this into a string. So we're going to return okay, string from UTF-8, path bytes. Context, converting path bytes to string. Okay. So now parse path from request is set up. So I should be able to do parse path from request and it the reader context parsing path like that. Okay. Okay. Right. Used binding path is possibly uninitialized because I need a loop through this to do it multiple times based upon where we are with this. So I probably just want to use an infinite loop like this. We have to match the state that we're in. We're going to get the method and the path, and we're going to set them out here. And then after every single one that we do this with, so if I do method, I probably want to call next on this and like move through and get the next one. Or we just say like, hey, we did the method, now time to get the path. So my state is not mutable, but if I make you mutable, I don't want to call this next. I think that looks a little bit weird. Is this website recommended for somebody still in college, BTech 4th year? It's a little bit expensive for college, I would say. Unfortunately, Rohit. Also, hello. How are you doing today? But yes, you can absolutely put these projects in your resume, and you can. I would probably try to find like some flair to do with them, so it's not exactly the same. But I don't think enough people are doing CodeCrafters that you would basically look it because everybody does like a to-do app, right? Like, so you can't put a to app in your resume, but with something like this, you're like building, I made an HTTP server. Go ahead and do that. I would also try to put some flair on after you're finished the project in order to make it yours just a little bit, because then you can also say like, hey, look, not only did I follow the challenge, I added my own thing to it, further trying to cement that you understand how this entire thing works, how the server works. Does that make sense? Okay, parse state. What are we calling this? Like we could do next state. So move on to self. I don't want to return anything. Ooh, I could do so we have a done. So when we're finished, so we can say, let's match on self. So if we are self method and we run this, then I want the next one to be a dereferenced self is now going to be self path, like that. If we're self path, then a dereferenced self is going to be equal to a self. All right, so we need to see what are all the different things we're going to get out of here. So we have method, path. I mean, we'll probably have like query and other stuff. Is that protocol? So protocol headers body. So protocol headers body. Protocol headers body. Okay, so self path that goes into then protocol is next. Self protocol goes into. Oh, and since I'm doing this like that, let's just do this. Now you can be self headers. Okay, if we're self protocol. Okay, so if we're headers, we become self body, and if we're body, we become self done. Oh, and then done. Self done. And then in this case, I want to panic. I don't know if I want to panic. So I shouldn't call self like next state on done. If I do, what do I want to do? Like there's so many different things. I want to go back to method. I could just stay on done and just nothing happens. Or I could print something out saying like, hey dummy, you attempted to call next state on done, but that's not a good idea. That might be the best thing. So let's try like just standard out, or I could return a result and this won't change anything. So we're okay there. Okay, so self, let's do like that. So if we're undone and we called this, I want to bail, and we're going to say cannot call next state when state is done. Okay, that makes you happy. We do that. We update you. So now I can do a next state. Okay, so we have our loop. We match the state in here. In method, I want to do your entire thing and then state dot next state. What are you upset about? Cannot mutate immutable variable method. Right, I'm missing. Okay, so hold on. Fail to match arms. It's never red. It's red down there. Oh, wait, I think I know what's going on. It's the loop. The loop is making things weird. Okay, so if we get to done, then I just want to break out of the loop. That's all I care about. Break out of the loop. And I was really hoping that I wouldn't have to do a builder, but I think I do. I think we need to do a builder there. Havany, I did not get to see your message, so sorry about that. But hello, how are you doing today? Let's see. RG Brewskis, hello, how are you doing today? We are constantly striving to improve our and your software development. The comma misplacement drives me a little nuts, not gonna lie. Which comma placement? I missed where exactly that was, so I don't know when you put that in there. Artemids, hello, how are you? What is CodeCrafters? CodeCrafters is a website that you can go to that has challenges. So here we can see, I'm doing the build your own HTTP server challenge right now. I'm using Rust, but they have all these different challenges that you can do. It looks like the build your own interpreter challenge is free right now. So that is something to check out if you don't want to pay for it. And then they support all of these languages. Note that they have like X number of stages on here. That means that not all of the languages are supported by everything, except I believe Rust, Go, and Python are supported by literally every single one of their challenges. They have them there. But yeah, that's what CodeCrafters is. Do I even need a loop here? The order of parsing operatives is deterministic. Oh yeah, that's true. I don't need a loop there. Yeah, that's a good point. Okay, so here we see a software engineer being overly complex when they don't need to be. Do I even need a state at all anymore? Probably not. Hold on, let's just start this over again here. What if I just do, okay, this is going to be a request, or I guess I could do here. Okay, let's do let method parse method from request, pan it the reader context, parsing method. Okay, then request, and we have method and path. Okay, yeah, I don't even need the state anymore. So all of this stuff that I was doing goes away, which is always nice when we delete code. Okay, much better. And so now we have our method and our path. We get that, we parse that out, we exit, we return out of view. We're looping inside of here. Right, read the stream, that needs to be the loop. And then, okay, then we print the request. So we should now see inside of this, we should now see an error. Starting to listen, receiving incoming message, misspelled. About to read stream, looping will get in chunks. We read 88 chunks, got all the chunks, got request, parsing error request. Error status 1. Wait, did that not print out the way I expected it to? I thought that would print that out, but parsing raw request was the last thing we got. This. Okay, so parsing raw request. Interesting, I didn't get parsing method or parsing path from request, so those didn't fail, right? If I do that, oh, you need to be debug mode. Yeah, I didn't see anything. Okay, nothing came out as part of that. Well, that's fun. Let's see. I'll wait until the ad break is done before I continue chatting with chat. Okay, so what is going on here? Now, parsing raw request. I attempt to do the use. So we don't get these out here, but I'm wondering if maybe there's something weird going on with this. So if I do like more print lines, because we love those. So we're about to parse method. Now, I believe that works, right? So about to parse URL. Hey, welcome back, everybody. Okay, so what do we miss? So we talked about CodeCrafters. Perfect place for an M dash, which I don't think I did. Do you even need a loop here? Yeah. Okay. So I took out the loop. Welcome to Brooks Builds, where we are constantly striving to improve that's what you mean. And your software development leadership and productivity. Okay. Good point. I will try to remember. So add M dash to, I guess like that's my Twitch about, and then in my notes, that is, and your, wouldn't the M dash be like and your, okay, now I'm questioning my ability to do any English at all. Because none of that sounds right anymore. I'll do that for right now. That's a pretty cool challenge. Yeah, I think a lot of the challenges that they have are pretty cool. All right, so I've got this all up and running. We added some print lines in here. Let's go ahead and run you. Okay, about to parse method, and that was it. And then we had parsing raw request. So about to parse method, which means inside of here, we had an error. So read until space. So this is print line, I guess like a reading method from reader. And then there's the try from. So it could be there too. So print line, converting bytes to method. Ooh, so I got to the converting bytes to method, and this try from failed here. So that makes me curious. Can I look at method string get? Okay. So we can actually see method string get. You could change the try from to pattern match the bytes directly. I could. Yeah. I mean, that would be the fastest way to do it and probably the best. But okay. So a method string get like that, which means that, hold on. I think I know what the problem is. It's a space. There's a space. Trim just gives me a stir. So I can replace as stir with trim. And then that should hopefully work. There we go. Now we have exactly what we want. So fun fact, changing the pattern to match wouldn't have worked because there was that extra space in there that we had gotten. I just trim here and then we're fine. Okay, so now we have access to the request, method, and path. Now the same for the path. Yeah, because the path has that space in there too. So let's do parse path from the request. Okay, so path bytes, string from that trim returns. Okay, there we go. Now we have method get and path, whatever path I put it in, like that. Perfect. Okay, excellent. All right, so now we have enough. I'm gonna stop working on like parsing now because we can now solve this problem, right? Which is if the path is not slash, we return a 404 error. So in run for stream, we want to set what our response is if it's a slash or an index to HTML. Try, can you put space in a URL and see if curl automatically encodes it? Oh, yeah, we could do that. Sure. Nope, wrong one. I want that. Let's do curl. Curl doesn't even hit the server with a space in it. Can I try quotes on it? No, malformed URL. So yeah, it curl won't even let me do that, which is nice. Yeah, it is nice there, but I wonder if we could use something like Insomnia to test it with the space, because maybe Insomnia does the wrong thing. So if I were to say, oh, this is mostly behind you. Okay, so go to what am I listening on? 4221. Okay, I want, just give me new request. Okay, HTTP localhost 4221 / okay, so path, let's double check that works. That does. It's gonna, okay, so it looks like Insomnia is going to encode it properly. And so we see that coming in here like that. So perfect. Okay, works as expected. And if I do multiple here, we get that. So I think it's working the way we expect it to. All right, so we have a request and we want to check to see if the request is for slash, because if it is, then we do a 200, and if it is not, we do a 404. Now, if we were to hard code this in here, which, like, isn't the best of ideas, but we can do that. So if our request.path, if that is equal to the equivalent of, actually, you know what? I haven't even tested this. If I just do like that, that's path is slash. If I add a slash onto it, path is slash. Okay. So if path is just slash, and that's all it is, then I want to send, so our response code, we can set to be 200 by default. If you are not slash, I want our response code to be 404. So really, okay, so if you're slash, we're going to turn 200, else return 404. You don't need to be mutable. You need to be formatted now. And then you're going to be the response code. And then everything else is going to be exactly the same. So now when I hit this, if we curl to this, we get a 200 OK. And if we curl to anything else, we get a 404. So let's get rid of our one warning. Method never used. Oh, do we have to also check if it's a get? I don't remember if we do need to or not. I'm going to leave this as a, I'm going to say that this is okay for right now. But okay, let's test to see if this works. And then if it does, we have 20 minutes or so to refactor. All right, so in our library, we have first pass responding with 200 OK on slash. Let's find out if this works. It took long enough for me to write that they spun down the whatever system that they're building all my stuff in. That's fun. Okay, so they built it successfully. It's now going to run our code. Okay, so it looks like the only thing, the problem was that the message was supposed to be not found. Yeah, you're right. Shouldn't it be HTTP 1.1 not found and not 404 OK? I mean, I guess if you want to be appropriate, yeah, it should be. Okay, but yes, you're right. It should be, so that's the response code. And then based upon the response code, we should have a message. Now, this kind of makes me think that we should have an enum for response code. So like HTTP code. And so if we have something like OK, So we'd have okay, and we have not found, right? And then we'd have an impl for HTTP code. I want to, you know what? If I want to toString this, I don't impl that myself. I do an impl toString for HTTP code. Oh, I could impl display. Oh, impl display for it. That's even better. Yeah, let's do that. Impl display, format display for HTTP code. Okay, so all we need to do here is we need to format this and then we write out to it. And let's get I guess we'll get the message, right? So we'll get, it's two things. It's the number and the message based upon these. So I kind of want to do this as a tuple type. So we can let, this will be the number, is that code number? Like number message equals, and then we're going to match on self. So we're going to have self okay. If we get that, I want to return 200 and okay, like that. I wonder if I need to turn that into a string. No, I probably don't. I don't need to turn that into a string. Self not found is going to be for a 4 and not, is it all one word? Was that what it's supposed to be? No, 2 words. So not found, like that. Okay, so we have access to number and message there, and now we're just going to write. The first thing I believe is the formatter, so F, and then everything else is the same, the way we expect it to be for like a print line. So we're going to write, that is how write works, right? Yes, exactly. It's exactly the same as print line at this point in time. Okay, so I want just the number, right? So we want the number space the message. Am I supposed to do a new line before now? I don't think so. I think that's it. Okay, so then I return you, you're okay. HTTP code. Okay, so we need to, I need to convert into the appropriate HTTP code, which is response code equals, okay, so if you're slash, I want HTTP code, okay, else HTTP code not found. That gives you that. And then it gives me, okay, then this display should work as expected. And then we should be fine. So if I run this again, so if we do our curl again here, we get not found, okay. Good thing I tested that. 404 not found, okay, excellent. All right, that should be good to go then. So we're gonna now commit, and this is now also sending the correct HTTP message. Let's see if this works. It did not. Okay, so what did we do wrong here? Expected reason to be not found got not found space. I didn't realize that space wasn't supposed to be there. Okay, well, there we go. Now we know. Removing extra space after HTTP message. Try again. There we go. Tests are passed. And we can see what the tests are. They passed in, okay, so they passed in blueberry and slash. And we got the 200 status code. Excellent. Okay, so looks like everything worked out just fine. And what would be next would be refactoring all this, because this is all inside of lib. And if we look at, we're at 153 lines, and most of these are just stuff that I've made for parsing. So that should probably all go in its own file. So that's what we're going to do next time. Hello, good morning, happy Monday. How you all doing today? Let's see, OBS looks good. Mic is on. I think we're ready to go. Isitsu, hello. How are you doing? All right, so today we are continuing to work on the HTTP server. That's the CodeCrafters challenge for creating our own HTTP server. We're doing it in Rust. And last time we got through the challenge of responding with, I think, a 200 request and maybe like a message. But what we have, I think, everything inside of main. Oh, we did move a bunch of stuff over into live. Okay, so that's good. We have this in main. We have this in our library, but I think, yeah, it's 153 lines. So I think we want to move things out into their own files and make things a little bit better. You're making great progress on your project. Excellent. That's great to hear. Hedgehog, hello. How are you doing today? Nice to hear what was in part 1. Yeah, so yeah, it's only been one part, right? Just last week? I want to say yes. But yeah, we got through. Let's open up the challenges. Oh, and of course I'm not logged in. Hold on, give me a second. Okay, well, apparently I just clicked the login button and it brought me right to here. So we are on the build your own HTTP server. Right, we just did this one, the respond with 200. And then that was, yeah, we just want to respond with a 200 request like this. And so that's what we've got. So looking at what functions we have, let's look at our symbols. So yeah, we have like the read stream for like reading incoming type things. I wonder if I want to put that into its own file. Parsing a raw request, that's also like part of incoming, right? Figuring out what the method is. Yeah, so like there's a bunch of this parsing that we have. I have a const space in here twice. So again, its own file would be helpful for that. Request. So a request struct that we return from it. So I wonder if I just want to create a single request, like process request file, and then we just throw all of this stuff in there. That might end up making sense. Because then we have the method type. That methods can be either for the outgoing and incoming. So wait, is that true? No, that's only incoming. Because I can't like respond with another thing. I can't respond with like a post. It's been quite the journey. Started with JSON, moved to SQLite via SQLX, and then SQL ORM. Sorry, CORM. Then back to JSON. Now you finally settle on the custom graph data structure. Oh, that is a fun sort of journey. But by the end of it, I'm guessing that you know exactly what you wanna, like what you want and why you want it, right? What's the structure of the entire server, or does things one by one? Here, yeah, let's go over it. So in our main, we don't really do much. We just run, right? So in run, which is in our library file, we create and set up the server, and then we set up the stream that's listening to incoming connections. And then for every connection that comes in, it's part of this loop here. So every time that a connection happens, we now receive a stream from this. So we then read stream, which is ours. So that's this read stream here. And let's see, read stream, that gives us the raw request. So this is just, what I do is I do a loop here to chunk through and get everything that we're getting out, because it might be bigger, like we don't know how big it is. And so I sort of like, we create this. You pretty much reinvented Neo4j and the Cypher query language. Oh, is that good? Or more of like, oh, I should have just started with that. I mean, it could be both, right? Let's see. Okay, so once we read the stream, that gets us a raw request, which is just a bunch of bytes. We parse this raw request into a request struct. We then figure out what the path is. And so this is a little bit of hard coding here. We don't have a router or anything sort of like to do stuff with that. We just basically say like, hey, if you're slash, then you get an okay back. Otherwise we get a not found. And let's see, then we have the actual response. So we figure out here's what the response is going to be. And then we send it on all back. Okay, yeah. So you're basically just doing a subset of Neo4j just for your own custom stuff, which makes a lot of sense. Like to be able to just basically use like just what you want, and you can control that really well, which is nice. Okay, so if we look at this, we have set up the server, which can probably be just in here like that. That's probably fine. But then we have our loop to go through here. That's probably also fine for this. But we have our, where's stream? Oh yeah, that's from this loop. So for this listener, we're coming in. Okay, so we're getting that. So we get our stream, and then this part, everything to get the request, this can go into its own file, I think. You are not the right directory. All right, so let's go into source. I don't think this needs to be a folder, so we're just going to call this maybe request.rs. Right, and that did update just the library. Now, what we probably want to do is call one thing, and it's going to respond with this request here. So I essentially want to do like, hey, read stream, and then that responds with the request. So I kind of want to grab these out, but then we're going to have a pub function get request or something like that. Maybe just, no, let's not call it request. Process request. It's probably going to take in something. We're going to turn a request, which I'm not going to worry about right now. Probably a result request. Yeah, this is definitely going to have to be a result request. So result, anyhow, result. We'll put in a request like that. And we'll get that. And let's just do an OK request out of here. Okay. So then that means we need to have a stream, which we see the stream is a TCP stream, just a TCP stream. Okay. So we have you. You're going to be upset for a short while until we get all the other stuff over here. So let's do that now. So that was read stream, process raw request, parse the method from the request, parse path from the request. Then we get this request here. Okay, so this is what we want to pull out. Okay, and then you need that trait. You need to be a mutable reference. Let's see. And as files should be managed as modules with names and import instead. Yeah, so we're going to put these into, well, this one's going to become its own module, and then it's going to have this process request function, which is sort of its interface to the rest of this module. And we just call that, and it's going to give us back a request. And then you don't need that there, so you're happy. Okay, method, right. So we should put this method somewhere else that's not here. And I'm wondering if maybe, yeah, we have like an impl for the method. Let's just create its own file for that too. I mean, it could be a helper, but I'm not exactly sure right now. Okay, so method, grab you. Do you need to be pub? I don't know if you need to be pub or not. Let's try that first. That grabs you. Okay, so then you're happy. Go back to you, and now we can say, all right, now, ooh, you couldn't find that. So you probably do need to be pub. Although, couldn't I go super? I might have been able to go super. Ooh. Use super method. Oh, wait. This needs to be pub. That's what the problem was. Okay. So then in here, I don't think you need to be pub there. Yeah, and you're still fine. So that's good. The only thing you know is crucial parts of the new file should contain the pub keyword. Yeah, so the pub keyword is for making it public so other files can access it. That's pretty much the big thing. The reason why I don't need to make this public in library, even though the request module is reading from method here, is because the request module is a child of lib. So that's where it gets a little bit interesting, right? So the child of lib has access to all the things that are modded from lib. So I can go like super, go one up from request, that gets to lib, and then into method from there. Now, if I wanted to go straight into method from request, then it would need to be public. I think that's how it works. That may be wrong. It might have been fine too. Okay, so your expected value. All right, so here we have the request. I don't want to worry about that yet. Let's continue on with request here. So we have read until. Right, so we have to just import a bunch of traits now. All right, so you're done. Now we just have the stuff in library. So you want to get the request. And so we have the listener, we have the stream. And so now I can just say, I want our request is going to be process request. And we hand it a mutable reference to the stream. And we can give you a context saying getting request like that. Now, your type is that expected. Field path of the request is private, right? So fun thing about having everything be in one file is in the same file, you have access to the arms, the properties of a struct. It just works out fine. But if you're in another file, these need to be public in order to have, or we need to create getters for them. So that makes you happy. Expected value found module request. And then you're only partial. Do I need to like resave you? Type request is private. Oh yeah. Wait. Pub function. You are pub. Process request is private. Type request is more private than the item process request. Oh, sorry. This thing needs to be public. That's what that is. Okay, and now just a bunch of warnings. So we can get rid of those. Field method is never read, which is fine for right now because we're not doing anything with it. I think that no matter what it is, we're just looking to the path, but eventually it's going to be, we're going to do something with the method. But okay, I think for right now, well, let's see. So this is not really a router, but we're kind of doing some routing here. I'm not exactly sure where and how I want to deal with this. So I'm going to leave it for right now. And then we have our response. Now the response I might want to throw into its own file because this should be fairly simple. We have, yeah, let's do a response of like what we're sending out, and then that can generate and build this out. And I might want to create a response struct that I create and then pass in here, and then it sort of like creates the thing. But that's all future stuff. And then that will actually probably take in a stream and then send that off on its own too. So there's only one place it's going to send out. Yeah, I'm going to want to turn this into a create response function at some point. Yeah, definitely. Okay, so grab you. Oh, don't want to do that. I want to create a pub function. Should we just call this response? I might want like a send response. All right, so we definitely want this to have a result, but we don't need to send anything back. We want the response code, which, okay, I figured this would be an HTTP code. Yeah, okay, so this wants to be an HTTP code, which should probably be part of response, right? So I'm okay with pulling this out of here, throwing you in like that. So we have our response code, which is going to be an HTTP code. That's going to be fine. Then we need the stream, which is going to have to be a mutable reference to the stream. And by stream, I mean TCP stream. Okay. We need to do an okay. Nothing by the end of here. That's fine. You're happy. You need to be public. Input display. We need to bring in format display. Write all. Probably that. And I'm doing a flush even though I'm not 100% sure I need to. Okay, and that's it. Everything is happy here. Then you're unhappy again. Right, so you need to import you. That gives us a response code, and then we need to use this with... Okay, so basically this becomes a little bit simpler. We are going to be a send response. We'll send the response code and a mutable reference to the stream. We'll context, sending response, and there we go. Okay, and that is happy. All right, so more warnings. And back to that method is never read, but that's fine. Okay, so that's the only warning. We're good to go there. Let's go ahead and send this on up and see if maybe we screwed up or if everything else is fine. Let's actually do this. Let's fully quit out. All right, so what did we do? I guess we refactored. We refactored the methods. Yeah, so we refactored methods in library to their own files. I know how to type. All right, let's see how this works. This might take a little bit of time because it's the first time we've pushed to this. I probably could have done a push right before the stream started to wake it up, but it's not that big of a problem. It doesn't actually take that long. Okay, and the test passed, and we can now move on to the next step. Excellent. And let's go ahead and do that. So down here, I believe we can say view next stage.